distance between 2 points. The other important concept is midpoint, which we've covered in the past, but we're going to review it. That should not be a difficult distance to find. You can just count, right? Or just notice the y coordinates are the same. So how far is it from 4 to -6? And again, 4 plus 6 is 10. So that distance there is 10. Same thing, easy, vertical line. Again, notice the -2 is the same. All we do is 6 to -5, distance 11. Distance always has to be positive again. You cannot have a negative distance. Would not make sense. This now is more difficult in that we can no longer count directly because it's a diagonal line. Still, we're going to use the same strategy though. How far is it from 4 to -5? How far is it from 6 to -3? Both of those answers come back to us as 9. So the distance horizontally and vertically between those 2 points is 9. Now there's 2 ways to approach. We can use this in the distance formula, or you could use what we call Pythagoras, because you notice this is a right triangle. We have 2 legs and a hypotenuse. So there's 2 methods. I'm going to go through the distance formula first of all, which I tend not to use, but occasionally it's something that we do have to pull out of the drawer, excuse me. All right, so you take your 2 x coordinates, which in this case are 4 and -5, and we subtract them. Doesn't matter what order we need to subtract them here because of that nice little square there. Yes. And again, looking at the x coordinates, 6 and -3, same thing. Again, we get 9 squared plus 9 squared, square root of that result. 81 and 81, 162, but 162 can be broken up into 81 times 2, no coincidence, so we end up with 9 radical 2. Method 2. Again, this would be, I think, the preferred, faster way to do this problem. Again, look at those 2 distances mentally and do that subtraction, and then just say, okay, well, c squared is going to be 9 squared plus 9 squared. So c squared is 162. So c is the square root of 162. Again, 9 root 2. Ignoring the negative answer. So there are the 2 ways. Hopefully I've convinced you that doing a Pythagorean approach is probably a faster way. And here we go. X minus x, y minus y. We need to differentiate between those x's and those y's, so that's why we put the 1 and the 2 there. Again, if I approach this from a Pythagorean approach, why it's just a squared and b squared. So this is the formal distance formula. This is the informal distance formula based on Pythagoras. They both, again, are springing from the same idea, the same concept. More on that later. So again, I look at 2 points, random points given to me, and we can say, well, how far is it from 11 to 3 and 10 to 7? Oops. And just say, okay, I got to square a number, square another number. So in this case, 11 and 3 is 8, 10 and 7 is 3. So 64 and 9, which would be 73. In this case, the square root of 73 would be my answer. That is a unsimplifiable square root. Midpoint of a line. You recall last trimester we called this the average formula, the common, ordinary, run-of-the-mill, and that was because instead of subtracting and squaring, what we're doing is we're adding the x coordinates and we're adding the y coordinates because I need to end up with a new point. This is not a distance, this is a point. Ergo, we need two values. So again, taking the 2 points I'm given here, 11 and 3 and 10 and 7, add, divide. I think it's useful to have a drawing so that when you're done you can look at your answer and say 7 and 17 halves, which I think is 8.5. I'll go with mixed numbers even though I don't like them in this case, just for a sense of like, yeah, that does make sense. 7 and 8.5 should be somewhere between 11 and 3 and then 10 and 7. Okay? Identifying the shapes. This is probably the most challenging thing. You're going to look at something, and let's say you're looking at a parallelogram and you want to show something as a parallelogram. You got to remember, first of all, what the definition is, and the definition is, yeah, opposite sides are parallel. So that means I need to, in this case, not look at distances, but slope. So again, from algebra days, what is the slope of this line and this line? And what is the slope of this line and this line? Well, those two vertical lines, or the two horizontal lines, right, have a slope of 0. So we don't need to do anything there. But the diagonal lines, I should kind of work on those. And so the slope 1 is going to be, again, take your x coordinates, subtract them, c minus 0. Take your, sorry, those are the y coordinates, and then your x coordinates. And so we end up with c over b. Doing the same thing on the second one. And you can label these up here on the chart if you want. But c minus 0, again, are the y coordinates, and the x coordinates, a plus b minus a. Watch your order on those. Make sure that you always subtract in the right order. We're not squaring in this case like we were in the distance formula. And voila. So I've proved that that is a parallelogram. Prove it's isosceles triangle. Well, an isosceles triangle means you've got two sides that are the same. In this case, we'll prove those two sides are the same distance. So again, you could call this C1 and you could call this C2. Again, I'm thinking Pythagoras in this case, yes. So a little triangle here, and this triangle is distance A and then B, because it's A and B over to get to that top. So I go C squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared. Please don't think that those square roots cancel the squares. That's a very common mistake that students do. So here's my first c value. Now c2 is a little bit trickier to do because we have to figure out, well, the height isn't tricky, it's still b squared. But the horizontal distance, how far is it between 2a and a? Okay, well that's a distance of 2a minus a squared, which I think you'll agree is just a squared plus b squared. So we end up with the same distance here. Yeah? Ka-ching, ka-ching. Going kind of fast here, not dilly-dallying. Find the length of the median. Find the length of the median from F to DE. So I got to go from F to DE. So I'm going to draw DE here. And then I got to find the length. How long is that? Well, to know that, I need to know the coordinates of this point. You could guesstimate, and it's pretty obvious at this point what those coordinates are. In fact, you could just look on here and say, oh, what's halfway between those two values. You know, you don't need to add up the 7 and the 9 and say 8. What is the distance from here to here and half of that? Well, that's pretty obvious to see. I don't need to add that up to tell me that we have a distance of 6. So in essence, I'm going from f, 6, negative 4, to 8, 6. Sorry, made a mistake there. That isn't 6, is it? Notice I got my axis is turned around. This here is the x-axis up here. So that distance there is negative 4. That's negative 2. Sorry. Okay. I thought my x-axis was down here. Now again, distance formula. Hopefully you're getting good at this. And I don't necessarily always use c squared, but if you want to use that as a reminder to use Pythagoras. How far is it from 6 to 8? That's 2. How far is it from negative 4 to negative 2? That also is 2. And so the distance is the square root of 8, which is 2 root 2. All right. And tomorrow we'll talk about triples.